Hi class, and welcome to Chapter 13. Chapter 13 talks about a variety of different ways that we can display data using charts and graphs, tools that are helpful in gathering big data sets and putting them into one picture that could be easily interpreted. So today we're talking about the histogram. And you guys have seen histograms before. In fact, you've seen many of them before. You've just known them as a different name. You've probably heard of them as being called bar graphs. And there's a little bit of a difference between the two, but they are very, very similar. And so a histogram, in a sense, is just a different kind of a bar graph. So we're going to talk about some different characteristics of histograms. So histograms are used for quantitative variables. And what quantitative variables means is that it's used for numbers. You see some different data collection things where it's, how do you feel about this topic? Do you agree, somewhat disagree, or strongly disagree? Something like that. Those are qualitative variables. Quantitative variables is meaning, obviously, numbers. What was your test grade on this one? That's a quantitative, that's a number. What was your bowling score in this bowling game? Was it 200 pins or something like that? That's a quantitative number. So histograms are used for quantitative variables. It's used to display large sets of data. So I could put, 200 different data entries all on one histogram. That's a pretty big set. You could do thousands on one data, on one display, one histogram. So used for large sets of data. What you do when you make a histogram is you choose an appropriate scale and then you scale evenly. Meaning, maybe I gave out a test, and maybe on my test I got grades of in the 50s, and in the 60s, and in the 70s, in the 80s, and in the 90s. And then I have my appropriate bars. Maybe there was 3 that got a 50. Maybe there was like 4 that got 60s. Maybe there was 12 that got in the 70s. Maybe there was 9 that got in the 80s, something like that. You choose a scale. The scale I chose was 10, 50, 60, 70, 80, 90, and you scale evenly. You wouldn't scale 50, and then 55, and then 65, and then 72, and then 83. You choose, and then you scale evenly. That's what you do when you make a histogram. If a number lands on the line, it should go in the bar above. So when you're making a histogram, if someone got a 53%, well then of course they would be in this bar. If someone got a 72%, of course they would go in this bar. If someone got an 80%, where do you put the 80? Well, if it lies on the line, here an 80% lies on the line, then it would go in the bar above. So whenever one lies on that certain increment, put it in the bar above. That's what that one means. Other characteristics of histograms. We get outliers, and outliers, you probably heard this term before. It's data that is way different compared to the rest. You're going to, right now it's kind of some gray area, but coming up in a later lesson I'll explain what this means in the parentheses. It says more than 1.5 interquartile ranges below Q1 or above Q3. So there is a cut and dry way to analyze whether a data entry is an outlier or not. For now, just know that it's data that is way different compared to the rest. The center of the data is the median, or the middle. So the center of a histogram is the middle of the histogram. The spread is the minimum to the maximum, ignoring any outliers. So if you have any outliers, kind of drop those when you talk about the spread. It's the minimum to the maximum, ignoring the outliers, the lowest score to the highest score. We talk about shape of outliers, and the shape is either skewed left, skewed right, or symmetrical. If it skews left, it means that it tails off to the left. If it trails to the right, if it's skewed right, then it trails off to the right. Symmetrical means that it's neither skewed left nor skewed right. You kind of have a good representation that's in the middle, and then it trails off to both sides rather evenly. This is where there's some gray area. You often hear statisticians saying that maybe it's slightly skewed to the left, or it's a little bit skewed to the right. They use those descriptive adjective words. It might not be clearly skewed left, but if it's slightly skewed left, you kind of hear those words to kind of cover up some gray area. The peak of a histogram is where the highest bar is, and hopefully that makes sense. It's the peak, the highest part of the bar graph of the histogram. Okay, so now we're going to talk about skewness, because we talk about that with histograms and with other data sets as well. So for this first one, we kind of see that the highest bar is off to the left, and then it trails to the right. If you can kind of make a smooth curve that kind of goes to the right, this would be skewed right. And some people say right skewed. Obviously, it means the same thing: skewed right or right skewed. This one would obviously be the exact opposite. It starts at the highest part to the right, and then it skews to the left. So this is skewed left. And then on this third one, you know, you can maybe make the case that it's maybe slightly skewed left. If you're kind of wondering whether it's skewed left or skewed right, that's probably an indication that it's pretty symmetrical. So we're going to go with symmetrical on this one. Symmetrical. It kind of trails evenly almost both ways, as it goes this way and as it goes this way. So this one would be symmetrical data. Okay, we're going to have an in-class discussion on this one, so save this for tomorrow when we talk about it all together. Now we're going to basically interpret our histogram. Here we have a histogram off to the right, and to get some context of what the data is talking about, this is the number of pairs of shoes owned by advanced algebra students. So I did a survey years ago, and here 15 students own between 0 and 5 pairs of shoes. And then there are 12 students that own between 5 and 10 pairs of shoes. And then you get more students, you get some students that own more pairs of shoes, 10 to 15 pairs of shoes. There were 6 of those students, and as you can see, the rest goes on. And look at this student over here. That person had 50 to 55 pairs of shoes. Whew! That is a lot of footwear. Maybe you have the same. Maybe you just have a bunch of flip-flops that are $1 a piece or something like that. I don't know. But that's what the data shows. That's what we're looking at when we get the context of the data. So when we look here, it says outliers. Are there any outliers in the data? Maybe you could argue that 50 to 55 is an outlier. It's still not crazy far away from the other data entries. So on this one, we would probably say none. There are no outliers. If you put 50 to 55, I'd probably accept that on a test because it is a little bit away from the others. But again, in a few days, we're going to have a cut and dry way to find outliers. There's going to be no guessing or gray area, and I'll teach that in a couple days. Okay, the center of the data is the middle. So what we would have to do to find the middle is we would have to know how many data entries there are. So if we want to find out how many data entries, how many students answered this survey or answered this questionnaire? Well, 15 plus 12 plus 6 plus 3 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. How many students does that total? We would add those all up, and that would be 42 students. So 42 students, and the middle, if you divide this by 2, that would be 21. So like, there's 21 students this way, and there's 21 students this way, so it would actually be an average of the 21st and 22nd students. That is the exact middle of the data. So where is the 21st and 22nd student? What bar is that in? Well, there's 15 students here, and we want to know where the 21st and the 22nd student are. So if there's 15 here and 12 here, that makes 27. That means that the 5 to 10 bar includes the students that are the 21st and the 22nd as far as their ownership of shoes. So the 5 to 10 bar would be the center or the middle of the data, 5 to 10. So I want you to understand that the center isn't like the middle of the graph, something like this. It's the middle of the data entries, and there's more data entries to the left than there are to the right. So that's why the center of the histogram is the 5 to 10 bar. 5 to 10 is the center. Let me know if you have any questions on that, if you need more explanation when you get to class tomorrow. The shape, I think we would all agree that this skews down to the right. So it's skewed right is our shape. Skewed right. The peak, what is the highest bar? The highest bar is the 0 to 5 bar. 0 to 5 is going to be our peak. So then our spread lists the minimum to the maximum, ignoring outliers. So the minimum is 0, the maximum is this 55. So 0 to 55. Again, if you said that this was an outlier, then the spread ignores outliers, so then the spread would be 0 to 45. Okay, so just so you remember, the spread always ignores outliers. We didn't say that we had any outliers, so our spread is 0 to 55. Let's try one more here altogether. When we're looking at this one, let's again get the context of the data. It's always helpful to read a graph when we know what the data is talking about. So the number of bedrooms in a dwelling by advanced algebra students. So once again, I asked this question: do you live in a 3-bedroom house? Do you live in a 1-bedroom house? Do you live in a 7-bedroom house? Do you live in a 2-bedroom apartment? Whatever the case might be, they answered appropriately. And it looks like 16 students, most students own or don't own, but live in a house or apartment that has 4 bedrooms. So that would be maybe pretty typical of Hutchinson's type houses. There are 11 that have a 3-bedroom house. There are 7 that have a 5-bedroom house. So right in the middle there is where we see most of our data. Are there any outliers on this one? I would say once again that there are none. There's not any data entries that is way different compared to the rest. If there was someone that had a 13-bedroom mansion, well, now that would be an outlier, but we don't see that in our data, so there are no outliers. The center is where the middle bar is, or the middle data entry is. So once again, we would have to add up all of these data entries. So what's 1 plus 3 plus 11 plus 16 plus 7 plus 3? If we add up all those, we would get 41. There are 41 students. So that means that the 21st student, there would be 20 below, and then you get 21, and then there's 20 above. That would make 41 students. So the 21st data entry is the center of the histogram. Where is the 21st student at? Well, 1 plus 3 is 4. We got to get to the 21st. 4 plus 11 is 15. So that doesn't include the 21st student. And then 15 plus 16 is 31. So the 21st student lies somewhere in the blue bar in that part of the histogram. So the 4 to 5 bar would be the center. 4 to 5. Generally, for symmetrical data, that kind of leads into the next question, what's the shape? The shape is symmetrical. So generally, for symmetrical data, the middle of the histogram will be the center. So as you can see here, the middle of our histogram was the center, and that's generally true for symmetrical data. The peak is the highest bar. The highest bar is also the 4 to 5 bar. It peaks with 16 students there in the middle. So 4 to 5 is the peak. And then the spread is the lowest to the highest, ignoring outliers. So the lowest is a 1-bedroom, 1 till the highest is 7. 1 to 7 is our spread. The last one is we're actually going to graph, make a histogram. We're going to do this all together as a class, as an activity. So we will have 2 things to talk about when you get to class tomorrow. Let me know if you had any questions from the notes for today when I see you.